Well, what is analogs? What are analog signals and why do we need analog? Our acquisition of analog signals provides us with a wide range of inputs to process. And the analog signals will provide us with more information than just on or off states. And the analog signals can quantify external stimulus values. A sensor or other input device can provide you with ranges and various values depending upon its position. What we're going to talk about here, we're going to review digital signals, what a digital signal is all about, talk about analog versus digital, what the differences are between them. Analog inputs into the Arduino, what can we see? What voltage ranges can we see? Can we read negative voltages? How do we handle negative voltages? And how do we connect analog signals to the Arduino? If you remember about digital signals we've been working with, any voltage from 0 to 1.5 volts is seen by the processor as a logic 0 or off. And then any voltage from 3 to 5 volts is seen by the processor as a logic 1 or on. There is that gray area between 1.5 to 3, but typically the digital signals will be going back and forth between one or the other. 0 volts to 5 volts or 0 volts to 3 volts. Now this is an example of a digital signal that we have. In looking at this signal over time, you can see that it varies, starting down here at 0 volts and will go up to 5 volts. And you can measure for how long it is on for by looking at the time between here and here. You can also measure the off time, how long it is at 0 volts. So as far as the Arduino is concerned, as soon as any voltage between 0 and 1.5 volts along this line here is considered a logic 0. Any voltage from 3 volts and above is considered a logic 1. So it has two states, either on or off. That's it. If you look at this slope here on this line, the transition time from a high to a low, that is typically very fast in the order of nanoseconds, and relative to the other signals, the processor will see that as either an on or an off. It will not record individual voltages as it transitions from one state on to off or off up to on. As we said, the digital has two states, on or off. That's it. Analog signals can have a wide range of values. When we read values of 0.25, 0.75, 2.5, 3, all the way on up to 5 volts, anywhere from 0 to 5 volts, you can go and sample and return a quantized value of your analog signal. The analog also allows for real-world control. You can sense input sensors that vary from 0 to 5 volts and then use those to control motors or report results like temperature values. A temperature is not either on or off, but a temperature is a continuous value that'll go from a negative range all the way on up to a positive temperature. In our case, we would sample temperatures from 0 degrees centigrade all the way on up to 150 degrees centigrade. An example of the difference between digital control and analog control are the switch box controls for the ROVs. If you turn the switches on, the motors are on full power. The thrusters are going full power. The easiest way to see this, if you want to turn right or left, you turn one switch forward, one switch reverse, and the ROV will lurch right or left. Whereas if you were to do that same control with an analog system, you'll have a smooth ramp up to full speed and then a smooth ramp down to off. Here's an example of an analog signal superimposed over the previous digital signal that we saw. You can see the digital signal in red and the analog signal in blue, varying up and down, up and down. And if you were to go along and sample at various points, you can see you have values that are other than 0 or 5 volts. And by feeding this analog signal to what is called an analog to digital converter, we can convert this signal into digital numbers that can be processed by the Arduino. An analog to digital converter is a device that will convert this signal, and its value will depend on the number of bits that the converter has. Your Arduino has a 10-bit converter that has a range of 0 to 1024. We'll talk more about that later, but for right now, an analog to digital converter converts analog signals into digital numbers for use by the Arduino. So the analog inputs to your Arduino, what can we see? Any analog signal into the Arduino must be between 0 volts and 5 volts DC. Signals must be positive. Negative voltages cannot be directly sampled by the Arduino. Well, how can we read negative voltages? Again, the minimum input is 0 volts. Maximum input is 5 volts. I keep repeating this because these are important numbers that we need to remember. We can read negative voltages as long as the voltage swing is no more than 5 volts peak to peak through a method of capacitive coupling and DC injection, but we will cover that towards the end of the course. Alright, how do we connect up the analog signals to the Arduino? The Arduino has a number of special pins. And some of them have analog input capabilities. If you look over here, you'll see these pins A0, A1, A2, A3, A4, and A5. Those are the analog input pins to the Arduino. It can sample varying signals between 0 to 5 volts, and any signal that is connected there can be treated as analog. It's as simple as wiring it up, and then in your code you'll declare the pin as A0, A1, A2, A3, A4, or A5. The other pins, D0, D1, all the way on up to D13, are digital only. These pins can only be inputs or outputs, and of digital signals 0 to 5 volts only, and they cannot be connected for analog inputs. So in the next presentation we'll talk about analog sensor types. We'll connect a simple sensor to the Arduino and convert the analog signal to digital, and we'll display that value. And in addition, we'll develop a couple of programs to read sensor values.